Oh, hey everyone, it's Justin again. I've been researching the rainfall deep in the Amazon rainforest in Peru. I recorded the amount of rainfall over the past 15 days and placed the data in your warm-up activity. So make sure you complete it before continuing this video. Pause now if you haven't done so already. Okay, looks like you're ready to go. Let's get into it. Just looking at the data, what's the typical rainfall in the forest? Yeah, rainfall is typically in the lower 50s. Huh. Our median is in the lower 50s, but the mean is almost 60? Why is our mean so high? Oh, the 110 and 111 are unusually larger than our other data points, so they increase the sum more, which results in a higher mean. Data points like this are called outliers. They're much smaller or larger than the typical values in a data set. They lie outside of where we typically expect data to fall, so we call them outliers. On those 2 days, there was a huge storm that we don't really see in these areas. That would explain why we had these outliers. These outliers are also impacting the range. Without them, my range would be 56 minus 49, a small spread of 7 millimeters, which makes sense because rainfall is pretty consistent here. But with my outliers, the range is a whopping 62 millimeters. Well, that's kind of frustrating. When it comes to a typical value of a data set, even though the mean is impacted by these outliers, we still have the median that gives us an accurate typical value. I wonder if there's another measure of spread that, like the median, would be less affected by outliers. Where would outliers appear in a data set? Since they're either unusually small data points or unusually large data points, they'll either be at the beginning or at the end of an ordered data set. Where are most of the typical values in the data set? Yeah, they're in the middle. So maybe we should leave off the ends and find the range of the middle section. But where do you think the middle of the data is? Is this the middle? How about this? Let's imagine that the data is represented by this rectangle divided into 4 quarters. Which sections would you shade to represent the middle of this rectangle? We would leave off one section on each end and shade these 2 pieces in the center. That way, none of the ends are included in my middle. We could do something similar with a data set. If we break it up into 4 quarters, we can use the middle 2 sections to represent the middle of the data. How can we separate our data set into equal quarters? We already have the median, which splits our data down the middle. The left 7 numbers are the lower half, or lower 50%, and the right 7 numbers are the upper half, or upper 50%. How can we take these halves and create quarters, or 25% sections of data? Yeah, we can split each of those 50% in half to create quarters. Let's focus in on the lower half of our data. How can we split this into 2 quarters? If we knew what the middle number was in this half, that could help us split it into 2 smaller groups. Oh, I know. What if we find the median of this half of the data? Go ahead and find the median of the lower half of the data. We can use the strategy of crossing off a number from each end of the data until we have a middle value, giving us a median of 50. This number is known as the first quartile, or Q1. We call this number a quartile because it helps break up the dataset into quarters. Q1 is the median of the lower half of a dataset, the point where the first quarter meets the second quarter of the data. All right, now let's take a look at the upper half of our data. What do you think we should do with this half to break it into 2 quarters? Yeah, find the median of this half of the data. Go ahead and find the median of the upper half of the data. We can use the strategy of crossing off a number from each end of the data until we have a middle value, giving us a median of 53. This number is known as the third quartile, or Q3. It's the median of the upper half of a data set, the point where the third quarter meets the fourth quarter of the data. Our Q1, Q2, or median, and Q3 indicate where one quarter meets another quarter, splitting our data into 4 quarters. These quarters do not include the quartiles, since quartiles are the boundaries of the 4 parts. Now that we have our 4 quarters, we can identify the middle section of the data. Where would that be? Yeah, these 2 middle quarters here, or the middle 50%. Now we just need to find the range. How can we find the range of this middle 50% of the data? Just like for the range of a whole data set, we'll find the difference between the highest number and the lowest number. What's the highest and lowest number in this middle 50%? The highest number is 53, represented by the third quartile, or Q3, and the lowest number is 50, represented by our first quartile, or Q1. We could do 53 minus 50 to see that the range of this middle 50% of the data is 3. Since this isn't the range of the whole data set, we don't call it the range. It has its own name, the interquartile range, or IQR. It shows the spread of the middle 50% of a data set and is the difference between the third and first quartiles. So, what does it mean for the data set to have an IQR of 3? The middle 50% of the data has a spread of 3 millimeters. So on a typical day here, it rains a really consistent amount within 3 millimeters. Now, let's compare that with the range of the entire data set. The range of the whole data set is 62 millimeters, and the IQR is 3 millimeters. Why is the IQR so much smaller than the range? The outliers at the ends of the data drive up the range, but the IQR is the spread of the middle of the data, so the outliers just aren't included in the IQR. Does the range, or IQR, represent the typical spread of rainfall better, and why? Pause now to write down your response. Since the IQR focuses only on the middle 50% of the data, it ignores the extreme rainfall days, or outliers like 110 and 111. That's why the IQR best represents the typical spread of data sets with outliers, like this data set of rainfall. Ooh, that's my cue to check how much rainfall there was today. Oh man, that was a trek. See that object behind me? That's my rain gauge. And today's rainfall is 72 millimeters. Okay, let's put that in with the rest of the data. We want to maintain the order, so which 2 numbers should 72 go between? Yep, right between 56 and 110. We should find the IQR for this updated data set. What's my first step? We have to first find the median so we can split the data into the lower and upper half. Since this updated data set now has an even number of data points, we'll have 2 middle numbers. The median would be exactly between them, or just their mean, giving us 52. Now we can split the data. The median splits our data down the middle with 8 numbers each on the lower and upper halves. What's our next step? Yeah, we need to split them into quarters. Then what do we do? Yep, we find Q1, which is the median of the lower half, and Q3, which is the median of the upper half. Subtracting Q3 by Q1 will give us the IQR. A storm's coming. I gotta run. After you calculate the IQR for this dataset on the IQR worksheet, jump into the practice levels for today to review your work. Good luck with that, and we'll see you next time.